All of you can see, no? This is what we did in the last class, isn't it? This is what we did in the last class, and I think I'll do it like this. And we will just try to do it again here. Okay. So the idea is as follows. So I want to plot cos theta, and this plotting is called polar plot. Okay. Where do you get cos theta? Can anyone tell me why I'm plotting cos theta? This is for an orbital, isn't it? Which orbital is this?
PZ.
PZ, yes. So any PZ orbital, you will see you have a cos theta from the angular part. And since this is PZ, there is no phi dependence that you must have seen. So the plotting is as follows. Just you make a list of theta and what is known as cos theta. Okay, like here, theta cos theta. I know the values of theta. 0 degree is 1, 30 degree is whatever. Huh? How it is fine. Okay, and then we know some values are positive, some values are negative, and then I start plotting. How do we plot? First we draw two axes. You have to draw the z axis first, and then y or x. They are equivalent actually in this case. So let us draw z axis and y axis. Okay, so what is the value of this cos theta when your theta is 0? Now theta, you remember, this is the angle theta, isn't it? This is the angle theta, the angle between the vector and whatever, the z axis. Okay, so first you choose the value of theta 0 degrees and the cos theta is 1. So this magnitude, this length is equal to 1. Is this clear? That this length is equal to 1. This is how we plot. Okay, so we choose a length, this is equal to 1 from the origin. So that's why you put a point here. Okay, what will be the next value? 0.85 at 30 degree. 30 degree means maybe somewhere here, and this is where your 0.85 is. Okay, you are following? Please write in the chat box at least. I hope you are following.
Yes, sir.
Yeah. So the next one is 0.7, which is 45 degree. 45 degree is this angle roughly. So the 0.7 may be here. Okay. The next one is 0.5, which is 60 degree. 60 degree is where? Okay, maybe here or here, whatever. Huh? And the next one is 90 degree, and the value is 0. So I have to put the point here. Because 90 degree and the value is 0. But now again I go above 90 degree. I go to 120 degree. What is the value? The value is minus 0.5. But I have told you that when you do a polar plot, don't take the minus sign. Just take the magnitude. What is the magnitude of minus 0.5? It is 0.5. Okay. So 120 means somewhere here. No. 120 means what? The vector. This vector will come somewhere here. So this is the vector drawn. No. 90 degree means along y-axis. 120 will be something here. Somewhere here. And when it is 120, the value is minus 0.5, but I take only the magnitude, so it is 0.5. This is where it is. Next one would be what? 135 minus 0.70 something. So I should not take the minus sign. I should take the plus sign. Should be here. And then the next one would be minus 0.85, but I take only 0.85. And the 180, which is in the negative direction of the z-axis, the value is minus 1, but I take only the magnitude, which is 1. So this magnitude is also 1. Once I get the points, I connect these points, which I have done. You can do it also on the other side, because theta 30, this is 30 degree, then this is also 30 degree for theta. On the other side, the value of phi is also only different. Theta value remains the same. The theta value is from 0 to 180. So that you can do. If you want, you can do and complete it. And then you have to remember that, okay, when theta is from 0 to 90 degree, 0 to 90 degree, your values are uh, 0 to 90 degree, your values are positive. So this part, the values are positive, so I have to put plus. On the other side, it is minus, I have to put minus here, plus here. And this is how it looks like. Okay, but this is for along z axis. But see, there is no phi dependence for this function, so it is independent of phi. So I can draw the same thing between z and x, and your x axis would be something like that. It is coming out from your slide, so your x axis is going to be something like it's coming out, and it is coming out towards you, like this is your x axis. So on the zx plane, you can do the same. Okay. On the zx plane, you can draw the same polar plot. So you can do it in the zx plane as well as in the zx plane as well as in the xy plane, zy plane. And since it is independent of phi, you can do it at any angle, isn't it? Any value of phi is independent of phi. It's equivalent of saying that, okay, I can do it. Actually, I can do it on xy zy plane, and then make a rotation along z axis. So it will give you, when I make a rotation along z axis, this is symmetric around z axis. So this is what we get, what is known as the polar plot for pz orbital. Is this clear? Any question? It's very simple. Okay, and then you put plus here and minus here. Okay, so let us show you something. Maybe I can show it here. So what I had was this. Okay, let us do it. What is this? You know this? I can actually rotate and tell you. If it is your z axis, what is this orbital? Like, this is a polar plot kind of thing, isn't it? What is this? Can anyone tell me? If this is, I say,
PZ orbital.
this is a pz orbital, isn't it? That you know from your essentially exactly this. What I have done here, if you see it in 3D, it will be something like this, the one I showed you right now. Okay? Is it fine? Okay, so now let us move to something else. So let us now move to something else. I will tell you where. So even before that, I should do one thing. Yes, I should copy this. Copy and paste it. Okay. Now, okay. I hope you can see. So what I have put here, what are these? These are spherical harmonics. You know, no? What is the value of spherical harmonic when m is 0 and l is 0? Remember, I had done this 1 over 4 pi. You remember? This is exactly what is. And this is for which orbital? Tell me. For
S.
which orbital L is 0? Tell me.
S orbital.
S orbital.
Any s orbital you take. So it is independent of, this is for s orbital, isn't it? So the spherical harmonic, if I ask a question, say what is the value of spherical harmonic for s orbital? Your answer would be what? So a value I don't remember, sir. some constant, but it is independent of theta and phi. Okay. For that, you don't need to remember the expression for the spherical harmonic, isn't it? So for S orbital, it is independent of theta and phi. Because I just repeat, okay, I'm not admitting anyone from outside. Okay. So I just repeat that for S orbital, you remember the structure, what is the structure for which function? Which function structure was that the psi depends on L, M, N, actually NLM, I have written like this. You had something like R, and this is a function of what? Can anyone tell me this is a function of what? And then Y?
N and L.
LM. No, what about the functional form of R? Is it depend only on N or anything else? Who can tell me?
N. N
Only
and L.
Only N or L? Also L, yeah, remember. If you remember,
N and L.
yes, yeah, so a lot of noise there actually, so I don't know. So this is the structure, don't forget. So this gives you only the angular part. Part of the wave function. And this one gives you the radial part. Okay, the angular part you have, radial part you have. And this angular part is independent of angle for S orbital, 1 over root over 4 pi. Okay. So now we have done, what we have done? We have done psi to pz. We had done it. What was the expression? Can anyone tell me? At least you know there's a cos theta. I told you it's cos theta. And then you had some other constant, normalization constant. What else? What else was there? Can anyone tell me for 2pz orbital? We did in the last class. Don't remember? How many of you remember? See, you guys are not following. There's a problem. We did everything in the last class, isn't it? I said, okay. What is this? This is your 2pz. Some constant times r times exponential of minus r to a0. Why? How do I know this? This part will come from your r. This, also this part. Okay. So let us write it down here. So if I write it down, you will see that okay, whatever is there, some constant times r. And this is the structure. Remember? And what I have drawn here, if you see very carefully, when I choose theta 90, what is the value of cos theta? 0. So basically, theta 90 means this xy plane. This means actually xy plane. So what does it mean? So it means that xy plane is actually a nodal plane. It's a node, isn't it, for this orbital? What is its node? What kind of node is this? What kind of node is this? Tell me. This is an angular node. I hope people are following. Is it fine? If I write like this angular node? Please tell me something. I don't know whether you are following.
Yes, sir.
Yes,
Yes.
sir.
Yes, sir.
Okay. Yeah. So now let us do some other thing. For example, if I go back, I'll just concentrate on the theta phi part. Okay, YLM. Okay. Now if I write down this Y 0 1. 1 means m equals to 1. M is your magnetic quantum number. What is the value? Now you may not remember what is the value, some constant, but you remember that what is y? How many of you remember what is the structure of y? It has theta part and phi part. You remember this? Somebody says yes, whoever has a less noise. Okay, this is fine. This is the structure. Structure is like that. What about phi part? This one everybody should remember. Very easy. What are the phi part? It was something like exponential of I m phi. Remember this? You may not remember what is conversation, huh? And this phi part was actually this exponential. If m is 0, this is 0. So that's why there is no phi dependence. Also, you can see there is no theta dependence when m is 0. So this is the phi part. So if I choose y01, at least I know the phi part is going to be exponential of I m phi. Okay. And if you go back and check the expression of your what is that known as the theta part of the wave function, which is little complicated, but you will find that for one it will be sine theta. So what I have here is actually something like e to the power of I m phi times sine theta. Okay, is this clear? Is this clear? If somebody says yes, it's not very difficult. What about y 0 minus 1? Can anyone tell me?
Sir?
Yes.
Sir, it would not be 0, 1 or 0 minus 1. It would be 1,
no.
1 or 1 minus 1.
1, 1 or?
1 minus
yes,
1.
you're right. You're right. You're right. Thank you very much. So somebody should tell me. So this is 1, 1 because I cannot have a situation like that. Okay. But is this clear? What will be this 1 minus 1? Tell me. This 1 minus 1 is some constant. The minus 1 means exponential of minus I m phi, and you'll see the theta part has sine theta. Okay. But I have some problem with this. Not problem, but maybe some of us are not very comfortable with this function. What is that problem? Or what is that discomfort? Can anyone tell me? Some of you may have it.
Imaginary part is there.
So imaginary
yes.
part is present.
Yes, because some people are not that imaginative, so they don't like the imaginary part. I'm just joking. So we have this part, which is imaginary. This one, no? Okay. So actually, chemists, they don't like this imaginary functions, the functions which involve exponential of I phi kind of thing, I m phi kind of thing. So what they do, they say, okay, we will not take this, rather we will take a linear combination of this using this simple formula, which I know that, okay, if I take exponential of I m phi, this is equal to what? Cos m phi. Everybody knows this?
Yes, sir.
Yes, sir.
And then from there, actually, you can define sine and cosine in terms of exponential function, exponential of I m phi kind of function. And once you do this, then actually you can express, you can come up with functions which will no longer have exponential of I m phi and exponential of minus I m phi. And then we construct something, and these orbitals are known as, how many of you know this? These are called psi,
px and py.
And yes, and psi to py. So what are the magnetic quantum numbers for to px and to py? Can anyone tell me?
1 and minus 1.
That can't be defined.
Yeah, so that is wrong. So it cannot be defined.
It has
So
to be
because-
something 1 or minus 1. Means either of them.
No, it is not. That is a complete wrong thing. Your magnetic quantum number for this is not defined. It is not +1 or -1. It is better to say it's not defined, because it is actually a linear combination of this linear combination of this. These are function of +1 and -1, plus m equal to plus m. So you cannot really say what is the magnetic quantum number for any px py orbital. But let me tell you one thing. If you don't remember what is a functional sum of 2px and 2py, I'll tell you how to remember. At least you remember this. This picture everybody should remember. Everybody remember this, huh? Should remember. What is Z? R?
Cos theta.
So now I go back and check my psi to pz expression. What is this? R cos theta. That gives you Z, and that is why it is psi to pz. Okay? Can you see that? Yes. So what about say what do you want? Say what is Y? Y is
R sin theta sin phi.
So this is Y. It has to be R sin theta and then sin phi. This is fine? Sin theta, sin phi. What is Z? Sorry, what is X?
R sin theta cos phi.
X is this. It has to be R sin theta cos phi. Now you can tell me what is the expression for psi to pz, to px rather. Some constant. You do not remember, okay? But you should have exponential of minus r by a0 kind of thing from the radial part. Okay? And then you will have, I told you that, okay, you have sine, if it is x, then it has to be this. Okay? Is this fine?
Yes, sir.
Okay. Modern. This is fine. So what about psi 2py? Some constant, maybe this one, and then
R sin theta sin phi.
Now you understand why? Because this guy is what? This is what? This is nothing but x. This is what? What is this? This is nothing but y.
Why?
So that is how it comes. Okay? Is this clear? I hope this is clear.
Yes,
Okay.
sir.
Yes, sir.
Yes. But again, you see, you don't have this exponential of. I think I rather I'll just make it 1 here. So I'm explicitly taking 1, no? See, because if you see, I have written the expression here. The expression is something like some constant sine theta exponential of minus I phi. So how to get, you know this, that if I want to express something like sine phi, it has to be something like exponential of I phi minus exponential of minus I phi divided by twice I, or something like that, no? Something you have to do, isn't it? Just check. Has to be something like this.
Yes, sir.
So this way you can generate this function 2px 2py, because chemists love functions which are real and they want to visualize this function so that they can make a polar plot or any other plot. So the next question is, how do you make a polar plot of this? I'm not going to do it. Just tell me. You want to do a polar plot for this function, no? See, it is not very difficult because we had done already for pz to pz, isn't it? What is this? This is px and py. It will be exactly the same. What was z-axis? In this case, the first case will be the x-axis, and in the second case, it will be the y-axis. So you'll have two spheres. You understand? In case of z, it was along z-axis, positive and negative z-axis. But in this case, you will have the first case x for x, you will have along x-axis, and for the second one, it will be along y-axis. Is this clear? You can do it, but remember you have phi dependence here, of course, but you can do the other way, this way. So if you do this, what I'm going to get something like this. What are these? These are your polar plots for your. Can you see this? I don't know whether you can see it.
Yes, sir.
This is the polar plot for your px, py, and pz. Fine. But this is okay. So now let us move to some other orbital. So let us choose an orbital, something like psi 3, 1, 0. What is this orbital? Psi 3, 1, 0.
3pz. 3pz.
3p. Right. 3pz. Now, can anyone tell me what is the functional form of this orbital? Yes.
Radial part including cos theta. Some radial part will be and cos theta will be there.
Yes. Cos theta for sure, huh? Because pz means it has to be r cos theta. So r should also be there. Huh? Are you clear? R should be there. And r, if it is there, it has to be divided by a0. And then what else? What else? What do you expect?
E raised to the power minus r by 3 then on.
Yeah, something like exponential of, let us see exact expression. The exact expression. So I think yeah. Yes. So it is this L equals to 1. So it has to be this, and actually I want to see the radial part exactly. Yes. So this is your radial part. You can see. So the radial part is n equal to 3. I have done it. Huh? N equal to 3, isn't it? So the radial part will be something like this. Okay. You can n equal to 3 and l equal to 1. So radial part will be something like this. Can you see this? So this is your r. Sigma is your r. Okay. Can you see this? Sigma is your r. Okay. Can you see? Just
Yes,
tell
sir.
me.
Yes, sir.
Yeah.
Yes.
Some constant. Don't look at. But exponential of minus r times 6 minus r times r. Sigma is your r. Essentially r by a0. Okay. So I have already written this, no? R by a0. But see, the point is the angular part is the same. Because angular part depends only on L and M. Is it clear?
Yes,
For
sir.
all p orbital, L is 1, so the angular part will be the same. And M will change. M will vary from 0, 0, and we don't take plus minus 1, take linear combination. So there are 3 possibilities for pz, isn't it? Whether 2pz, 3pz, 4pz does not mean. So we know the functional form of the angular part of p orbital. Okay, you know, is this clear? So for pz it has to be cos theta. You understand? For py it will be, if I write down for example psi 3 1 say call it c for cosine. What will be the function? Tell me. It will be again r by a0 cos theta, not cos theta, sorry. Remember this, no? This sin theta cos phi. What is this? Actually, what is this orbital? Can anyone tell me? Can anyone tell me?
3px.
3p.
Remember, this is r sin theta cos phi. What is this? X or y? Go
X.
back.
X.
X.
This is, it has to be x.
3px.
So it has to be something like this is psi 3p x. Okay, it's fine. Okay, now let us come back here. I said that it is something like whatever. It is 6 minus r by a0 into r, some constant. This thing, you know, you don't know. You do not know, but I'll tell you also how to remember that. Not the functional form, but what will be the form. Okay, what about the radial part for 3px? Will it be same as for 3py, 3pz, or different? Think and tell me.
Same sir, radial part.
Same, sir.
Why?
Because it
Different.
L.
Because radial part has nothing to do with magnetic quantum number. Is this clear?
Yes, sir.
Yes sir.
So if I know the radial part of, see, if I ask you a question, the wave function for 3pz is given by this, then write down the wave function for 3px. Without the constant, you should be able to write, isn't it? You should be able to write, isn't it? Because you know that, okay, the radial part is not going to change, only the angular part is going to change, and you know what is x in cos theta, in theta and phi, it is r sin theta cos phi. So it will be the same radial part as for 3pz times sin theta cos phi. The constants you may not remember, okay? It is not very difficult. Are you following the logic? This is very important. I'm teaching you some tricks to remember. Are you following?
Yes,
Please
sir.
tell me. Yeah.
Yes, sir.
Okay. So,
Yes, sir.
okay, so you'll have the same thing. I'm not writing. I'm very lazy now. I can also have the same thing here. Okay, let me write. So now let us plot R3, 1, 0. What will be the plot? Tell me. C10. So let us actually calculate. Let us actually see what is the functional form for this. The wave function, I think it is written somewhere else. I had given you this list. So psi to pz is this. 3pz is this. Okay. So it has minus exponential minus sigma by 3. It's not sigma, minus sigma by 3. So sigma by 2 in this case. Yes. Sigma by 2 and sigma by 3. That thing can. Okay. You should not forget this. It has exponential of minus sigma by 3. Difficult to remember, but minus by 3 or not, huh? But it is minus sigma, you'll remember. Okay. So here also I think it is we have 2 here, 2 sitting here. Okay. 2. But this thing not easy to remember. But you know exponential of minus r kind of thing. Anyway, so what is the functional form? Functional form is something like, if I write this r 3131, what is that? R y0. This is something like constant, I don't remember, but it will be like 6 minus r into r. This is the kind of form, isn't it? Okay. Now can anyone tell me, if I plot this, how does it going to look like?
There will be one nodes if it is
One
a,
node.
yeah, which will be at r is equal to 6.
Okay. Okay. What about r equal to 0? It is 0. Okay, it is 0, and then it will go like this. It will increase or decrease. Tell me.
It will first increase and then decrease.
And then
Will continue. No, will not go up.
but you have to remember that you have, don't forget this. Now you tell me.
0 at r equal to a0.
Then it will tend to 0 at infinity. First increase, then decrease, become negative, and tend to 0 at infinity.
So increase and decrease. So, yeah, fine. So what about this part of the function? What is the sign? There it is. What about here?
It's negative.
Negative. What is the value here?
It will be negative.
0.
Radial node.
Yeah, yeah. And so there is a node. This is called a node, and this node is along the radial direction. That's why it's called radial node. But how many radial nodes were there when we dealt with 1s?
For 1s, there is no node.
0.
There is no radial node.
For 2s?
It will be 1.
For 2s?
For 2s, it will be 1.
Okay. So for 2pz?
0.
Any idea?
0.
2pz,
Radial.
how many nodes are there? Radial nodes? Tell me.
0.
0.
Okay, are you sure? Are you sure?
Yes, sir.
Yes, sir.
Okay, so let us see the expression. So 2pz is this, sigma this. So there is no radial node, isn't it? Because only when r is 0 or r is infinity, the radial part becomes 0. Okay? But for 3pz, you know, there is one radial node. What about so if I go to 3px, how many radial nodes are there?
1.
It will be same for 3px, 3py, and 3pz.
Okay, now let us now go and what is that called? Let us go and do what is known as okay. So did I do the density plot of 2s? I have not done it. No. So let us do it for 2s also. This is 2 minus sigma into exponential of minus sigma by 2 for 2s. Okay. So this is fine. Now if I do this thing, that psi of 2s, which is actually psi of 200, you will see something like this 2 minus r or sigma, whatever, into exponential of minus sigma by 2. So, okay, and then constant. And how many radial nodes? One radial node. And how do you draw this, the density plot for this? How do you do density plot?
We will take psi star and then we'll draw.
No, density plot means I can also, if for example, density plot means not always density. You can take psi and make a density plot of that psi. Density means, for example, psi density plot, not psi star psi. Okay. Okay, density plot does not mean always probability density. Okay. Here the density means it's a value of psi. Okay. So what will be you remember density plot for 1s, it was only a sphere. But as I go away from the center, your density will decrease, isn't it? Away from the center. So here, what is going to happen? Your density is very large, and then you go away from the center, density is also going to decrease. Why? Because if I plot this, what I'm going to get? I'm going to get,
Exponential term is also there.
yes, the exponential term is there. What am I going to get? Tell me how I'm going to get when
It will
two.
first decrease to 0 and then will increase.
No,
and again,
what is the value at 0? Some constant, isn't it? This will then if the r increases, which is sigma, what is going to happen? It will decay, and then at sigma equal to 2, it will hit the axis. It will become 0. Then it will become negative, and then it will become
so density will be positive only, right? It will go
no,
upward.
no. I am not. I am telling you, density does not mean here. I'm just plotting this part. Don't look at density. Plotting side to s. Just side to s plot. Function of r. Okay. Is this clear? Is this
Yes, sir.
clear? Yeah.
Yes, sir.
This is fine. The density, don't think it is psi star psi. I'm saying it is. Now, if I make this psi to s plot in terms of density, means not psi star psi. I'm telling you, Devoji. What I'm saying here, density means I'm saying, okay, you plot this, but on this axis. So like maybe it is z axis, this x axis, whatever you want to call it. But using these dots, what is going to happen? So here it is positive, and then at some distance, okay, radially at a distance sigma equal to r equal to twice a naught, you will have a node. What is that node? Radial node. That I done also, I think, did in the last class. It will be something like this radial node, and then again beyond that I'll have density, because if I not density, I'm saying beyond that I will have some value of psi to s, which is non-zero but negative. Okay, so what I want to
Sir,
get?
basically you are drawing contour diagram.
Yeah, it's like a contour diagram. No, it's not a contour diagram anyway. Like a contour diagram, yes. You must have you did not attend last class, so you don't come to class without attending. Did you see my last video? So this is also known as density plot in the sense, okay, this is my wave function, wave function plot actually. Now this part will be minus. Why Devoji is not happy? Devoji always thinks that psi star psi that I should call density. I'll do that. So if I do a density plot in that Devoji sense, okay, if I plot psi star psi, psi to s mod psi to s square, what is going to happen? If I plot this, you know what is going to happen? This will be what? Like this, always positive, and then I make this is psi 1s, and if I do the same, whatever x, y, z, whatever you want to call it, I am now going to do this. Only what is the difference? It will be very similar, the appearance, isn't it? But one difference is there. What is the difference? What is the difference? Can anyone tell me what is the difference? The difference is it is always positive because I am now plotting density. This is probability density. This is psi 2s mod square. This is probability density. Okay, if I plot this will be this, but again there will be no node, isn't it? Will be node or there is no node. There is a node kind of thing at this point, but there the density becomes 0, but then the psi star side becomes 0, but then again it fits some value. So maybe I'll also use a different color. I can use a different color if you want. So I have this and then this. But the whole thing is that here you don't need to put plus or minus because you are plotting something which is always positive. But here you have to put this. This is plus and this is minus. Okay. So similar thing you can do for say psi 310. I'm not going to do it. You can do it for psi 310. I'm not going to do it. And now I'm going to move to some other function which I'll show you that you must have seen this. Let us do it. Let us see. So
Sir,
if
what
I
is
now yeah, tell me.
sir, what is the basic difference between the two density plot? Only the plus minus sign.
Yeah, nothing here. In for it's plus minus sign. In one case I am doing a psi plot, another case I am psi mod of psi square. Yes, nothing else. Okay. Now let us do one more thing. Let us pick another orbital, and we'll pick something like which is called psi 320. So can anyone tell me what is psi 320? What is this orbital?
This is
3D orbital.
3D
This
Z.
N is 3, A is 2, and M is 0. Just to be M 0 means it has to be along Z axis. 3D. This is nothing but psi 3D Z square. You'll know this. So what is the functional form? I am not going to ask you because I am going to write it down. If we're looking at the expression, I'm going to write it down. So the functional form is something like sigma square exponential of minus sigma by 3 into 3 cos square theta minus 1. If you do this, it's something like sigma square okay. This is 3 cos square theta minus 1. No phi dependence. This is fine. This is okay, no? This is z this is dz square. So no phi dependence. And this is the radial part. Of course, we have constant on written radial part. How many radial nodes?
0.
0 radial node. So how many radial nodes will be there if I draw, say, 3D xy?
All 0. None of
Because the radial part is not going to change. The radial part is 0. So what decides how many radial nodes will be there? Is there a rule?
n minus l minus 1.
Okay. The OG says that okay, that is n minus l minus 1. What is the value here?
3 minus 2 minus 1.
So let us go back and check whether it works. How many radial nodes are there here? So here n minus l minus 1 is how much? 3 minus 1 minus 1 is, I hope it is 1.
1.
Okay. What about here? 2s. 2 minus 1 0
0.
1. Okay.
1.
So Devojit is correct, right? This is the formula. I can tell you this is the way it's calculated. Anyway, but I want to make what is another polar plot of this quantity. How many of you have done the polar plot for this quantity? You can do it. What you need to do, you have to make a table 3 into theta and 3 cos square theta minus 1. Let us make that table. Theta 0 degree. What is the value of cos 0?
1.
Any idea?
1.
Cos 0 is 1. So 3 minus 1 is 2. At least I know this. This is 2. And I'm not going to calculate. I have the table. I'm just going to copy from there. It is 1.25. Let us do it for 45 degree. It is 0.5. Then there is actually, if I put 3 cos square theta minus 1 is 0, you will see that when theta is 54 degree, 54.7, I think 54.73 degree, then this is 0. This is called a magic angle kind of thing. So this is, I'm just writing it here, okay? It will be quite useful writing down. Zero. What about the 60 degree? Can anyone tell me? Otherwise, I'll tell you. It's minus 0.25. It becomes negative. 90 degree, cos 90, I know. Cos 90 is 0. It becomes minus 1 then. Then 120 degree. Any idea? 120 degree is again minus 0.25. What about 135 degree? Is 0.25. And then 150 degree, what is the value? Is 1.25. Then 180 degree, it is 2. Okay, everybody has a calculator?
Yes, sir.
Yes, sir.
Have I done anything wrong here? Just tell me. Maybe I have done something wrong. I have written something wrong here, but you tell me what is that. This one. What is the value at 135? Tell me.
Minus 0.5.
Just check. It's minus or plus?
Should be plus 0.5.
Yes, plus 0.5. But I wrote plus 0.25, I think I wrote. This is correct. 120 degree is minus 0.25. I just want to be sure that I'm not writing anything wrong here.
Yeah, that's correct, sir.
Yeah. So let us now draw this. Okay. Right. What is the value at 0 degree? 2. So I put a, okay, let's use a different color. I have this option. So I put a point here so that this length from the center is 2. First one. Next one is 1.25. 1.25 means this is something like 30 degree and 1.25 is somewhere here. Okay, so yeah, let us do it here. This was 30 degree. For 45 degree, it is 0.5. Okay, it is somewhere here. 45 degree, 0.5. What about this 54.73 degree? 54.73 degree. What is the value?
0.
0. Then how do you put this? So basically, when your angle is something like this, your thing becomes 0, isn't it? And then what happens? Then what happens? At 60 degree, it is minus 0.25, but you have to take only the plus sign. Okay, is it clear? So maybe somewhere in between becomes 0, and then it becomes minus 0.25, but you have to take only the magnitude, which will be somewhere here. And then what will be the value at 135 degree? The value will be somewhere higher here. Okay. Then 150 degree, it will be what? Sorry, I have just because I have to do minus. Sorry, no, not this one. Yeah. Sorry, 60 degree is this point. Okay, this is 54 degree. This point. This is 60 degree. And then 90 degree. 90 degree means along y-axis. What is the value at 90 degree? What is the value at 90 degree? Tell me. Value is
Minus 1.
Minus 1.
but you have to take only plus 1, no? Somewhere here, the length is here. If it is 2, then this is 1. Now 135 degree, what is the value? 0.5. 135 somewhere here. The 0.5 would be somewhere here, isn't it? Then 150 degree, it is 1.25. Then 180 degree is, it is again 2. Okay. So now what I need to do? What I need to do? Tell me. I need to just connect this point. And I connect this point, I can also complete this on the other side. But it's not a very well drawn. Sorry, because I have drawing it here. I can complete this on the other side. You have to practice a little. It's not very difficult. So I'm completing it on the other side. And then I'm almost done, but I have to put the signs. Now tell me what are the signs. Devojit, you tell me. What are the signs?
Both the lobes on z axis will be positive, and this lobe will be negative on y axis.
Let us see. This is positive. I know. Okay. And
Yeah, that one also.
this one is negative. Okay, because there are 3 points which are negative. I have 3 points. You can see 1, 2, 3. I have many points, but I have chosen only 3 points. Negative. So this is negative. Okay. And then it is again positive.
Positive.
And you can do the same thing on the other side. Now, one thing I did not do, there's another angle which is 180 degree minus 54.73. I don't know what is the value. What is the value? 55, if I subtract from 180, what is the value? Like 125.27,
125.
isn't it?
Hmm.
So what is this angle? This is another angle for which this 3 cos square theta minus 1 is 0. It will be somewhere here. Devojit, this is fine? Or anyone else?
Yes, sir.
Value is 0 degree. That had not written. Okay. Now, so now if I go to 54.73, which is somewhere here, I know that this is the angle, maybe this is the 54.73, this angle. Any point on this angle, the value of the function is 0. But this is also there on the other side, isn't it? Like this, it's not very well drawn. But similarly, at 125.27, I have a line like this, I have a line like this. And then you can actually, what is have here, you have a cone. Very bad drawing, but I hope you understand. You have a cone. So basically what you have two nodes. So this is one node, this is another node. There are 2 cones. So how many angular nodes? These are angular nodes. So how many angular nodes are there?
2.
0. Okay, so angular nodes. There are 2. And what is the rule here, Devojit? How many angular nodes?
Is equal to L.
Yes, it is L. L equal to 2. Whatever the value of L, that will be the number of angular nodes you have for that orbital. Is this clear? So let us check this. I go back and check it. And go back and check it. For 3pz, what is the value? 3pz, L is 1. L is 1, no? How many angular nodes? Only 1. Because cos theta 90 gives you an angular node, okay? That is your xy plane. So like in z axis, for px also there will be another plane. And for pz also, py also there will be another plane. So for px orbital, for px, what is the angular node? Tell me. For px, what is the plane? Which plane is this?
YZ plane.
It has to be YZ plane. For PY, it has to be
XZ plane.
XZ plane. So you got it. Yes. Not very difficult. So up to that, this is fine. Now I'll show you something on Mathematica or somewhere I can show. Now I can make an angular plot of this 3 cos square theta minus 1. This is exactly how it looks like, isn't it? This is, and I can plot other things, and these are the polar plots. You can say in 3D, polar plots in 3D for other orbitals, like other digit orbitals. I'm not going to do it now. I'll stop, but I'll show you. I'll give you a brief overview of what we have done so far, and many ways how you represent. But before I do that, I must say that orbital is not a region in space where you have a high probability of finding the electron. It is nothing but the one electron wave function that you get by solving Schrodinger equation. Is eigenvalue equation. So whenever you solve an eigenvalue equation, you get a wave function, eigenfunction, and these eigenfunctions are nothing but they are like, you see very carefully, if you think carefully, if you go back to your class 12 physics, they are like what is known as standing waves. How many of you know or heard about standing waves? I'm sure some of you. I'm sure some of you have heard about standing waves, isn't it? How to create? So standing waves are created when you have walls. Okay, the wave flows, hit the wall, come back, again hit this wall, and after some time it creates a wave within this confinement, and this is called standing wave, which is not traveling, which is only oscillating in the perpendicular direction, something like that, isn't it? So for example, if I go to 1D box, all the wave functions are like standing waves. Here, even in this case, hydrogen atom, these are like standing waves. So your wave functions, orbital, are also like standing waves. They are not going anywhere. So orbital is not a probability of finding an electron within 90%, 95%. All these things are wrong. Whatever you have read, some of you have read. So orbital is nothing but one electron wave function. Is this clear? I hope this is clear. Any question? I don't think you should have a question because this is quite straightforward. If you have a question, tell me. If you have a question, you tell me. So I'll give you a brief overview of what we have done in hydrogen atom. And then we are kind of done with hydrogen atom. Not really, because next Wednesday we'll do what is known as angular momentum, and that is very important. Okay, we'll do in the next week. So let me give you a brief overview. So this is exactly what I had. Can everyone see this?
Yes,
all
sir.
this. Yeah.
Yes.
Yeah.
Yep.
This is exactly what we had. But we actually, I solved, kind of not solved, at least I showed you the recursion formula. And this is how you write all this. And also I gave you this functional form. Don't need to remember anything. And this is very important. This is the structure that you should remember. The first one, remember, it depends on only N and L. I think I have in another slide. And this is how you normalize it, because this is the volume element, and how the volume element comes, you can actually, I have a slide, you can have a look. I'm not going to go through in detail. And energy expression is minus 1 over n square. That is important. It is exactly the same what you get from both here. Okay. And this is okay, we have already discussed, isn't it? I'm not going to repeat. This is how get phi to px and phi to py. by taking a linear combination of this, isn't it? Okay. This we have done. These also we have done. Okay. And this is exactly what, this is how it is done. 1s, 2s, plus, then minus. Okay. The surface plot I did not do, so we'll just skip this. I can do it, but I don't think you get anything else just by doing it. And this is your probability density, total probability together. And this is your volume element, r square sine theta d phi, and it comes from here. Geometrically, you can get it. And also there is something called Jacobian. You can calculate the Jacobian and can get it from there. Another way of doing it. These things we have done in the class. Radial distribution function also did in the last class, and this one has all the radial distribution functions of different orbitals. Okay, and this is 2s. Can you see this? This is very nice. This is plus, and then you have a node, and then it is negative. Is this clear? Sorry, I have a. If you cut it down, it will be like this for the 2s orbital. Okay. And this we have done. What is this orbital? This is cos theta. This is pz. Are you guys there or left? Tell me. At least you guys are there.
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
At least
Yes,
you are
sir.
there. This you have done. This is exactly what we did. Huh? And this is called constant probability surface. This is called surface plot. What I'm saying. This is like plus and minus. I can show it like this. And we did not do much of contour. Maybe we can just skip contour plot, but briefly I'll tell you that if I have 1s orbital, the contour plot will be like this, because always it is positive all through, isn't it? It's like this. And if I have 2s orbital, your radial part has a node. Okay, as a result, if you do a surface, this is called the surface plot, you'll have a dip here. This is the xy direction, because essentially you take this quantity and then if you rotate along z-axis, you'll create this, isn't it? It's like that. This is not very difficult because you have a dip. So if I take for example, if I take this along radial, arm is radially, going along radially. Okay, so that you can make like this, and then it will be something like this. Not very difficult. So the 2s orbital would have something like a dip here. If you plot it, you have plus here and then a minus here, and you have a radial node here. And this is how you do in contour plot. Okay, plus and then minus. This is 2s. We have done it. 3s. How many radial nodes will be there in 3s? Tell me. How many radial nodes will be there in 3s?
There will be 2.
2.
Yeah, 2. And how many angular nodes?
0.
0.
Because s orbital never has an angular node. So for 3s, it should be like plus, then one radial node, then minus, then another radial node, and then plus. So that's why it is saffron color, then blue, then saffron. Can you see the figure? Can you see the figure?
Yes, sir.
Very good. So if I cut it, it will be like this. This is plus, this is minus, then plus. What about 2pz? Now 2pz we did, na? It's cos theta times something like r exponential of minus r kind of thing, isn't it? And we had plotted this radial part. So we plot this radial part, it will be like this. No radial node, one angular node. Okay. And from this radial part, it is possible to construct this surface plot like this. Okay. We are not doing that in detail, but obviously, if I go back and the angular plot is cos theta, remember it's cos theta. So the angular plot will have two lobes, one is plus lobe and then minus lobe. And you can make a contour plot like this. If you do the contour plot like this, it will be something like this. One is plus, other one is minus, and this is what is known as XY plane. If this is X, then this direction is Y. So this plane is XY plane, this plane is XY plane, and along this XY plane you have a node, that is angular node. On one side of the XY plane you have psi, which is positive. On the other side of the XY plane the wave function is negative. So you can put plus and minus, or you can put two different colors. Okay, even if you put two different colors, put plus and minus. Okay, is this clear? These things you can do it yourself, this 2pz orbital, how to do this contour and other things. I'm not going to do it in detail, but I've done the polar plot. That's important. From there, essentially I'm looking at this contour. This is negative and this is positive. Not very difficult. Now, can anyone guess say what will be the contour plot, say for that you have done for 3pz, for example, 3pz, what will be the contour plot? Like, can you tell me in words? How many nodes are there in 3pz? Tell me. How many nodes in 3pz? How many nodes are there in 3pz?
Two nodes are there.
One
node.
One.
See, cos theta will give me one node, isn't it? 3pz and 2pz will have the same angular part, isn't it? Because y depends on L and M. Only the radial part is going to change, and in case of 3pz, radial part will have one node, which was not present in 2pz. So one radial node, one angular node. Is this clear? Okay, we did that actually. Okay, so this is the radial node.
Yes, sir.
Okay, and one angular node. So now if you make a contour, it will be something like this. How many of you understand this? The radial node means what? You have two nodes, one is angular, one is radial. Okay, what is this node? Tell me. This line.
Angular node.
This is the angular node. This is what is this plane? X, Y plane actually, isn't it? Y is your in this picture, it is towards you. So this is your X, Y plane, and this is your angular node. But then you will also have a radial node. What is at a distance? Something like r equal to 6a naught. You have a radial node. So now let us start from here. From here, if I go in the one direction, my wave function are positive, positive, positive. But at a distance, when r is equal to 6a0, if you go to the any direction, if you are going radial, you can go to any direction, to your left, to your right. This is a projection on xz plane. So if you go away from this plane, xy plane at this here, and you go away, then your wave function should become positive, 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 and it is positive up to a point when your r is less than 6a0. When your r is equal to 6a0, this is a, okay, a, or you can call it a0, then what is the value of the wave function?
0.
0. So if I go radially from this plane towards any direction, say I'm just taking a position on xz plane, so it will be 0. So I'll have a node here. What is that node? This is called the radial node, which is a sphere. You can see this is sphere, isn't it? And then if I go beyond that, what will be the wave function? The radial part of the wave function, what will be the value? Radial part. It will be
Negative, sir.
Let's go back and check. It will be negative, and eventually it will become positive 0 asymptotically. So basically you have plus, minus, okay. and one angular node and one radial node. Is this clear? I hope this is clear. This is not very difficult.
Yes, sir.
Okay. This is your radial node, and if I do this is called surface of constant probability or whatever. So this is your xy plane. If I go like this is plus, then becomes minus, like this, isn't it? So I should have said like this, because this is a node, so this has to be minus. No, this is minus plus. I repeat, this is minus plus. This is plus minus. Okay, because remember this is a node, so the wave function should change sign. So if I say this is plus, then after this node on your right it will become minus, and here you have a node here, so this is plus. This has to be minus, and then it will become plus. Okay, I said something not correct just few minutes back. I just repeat. You have two nodes, one radial node, one angular node. Just consider the angular node. So one side of the angular node, the wave function would have the different would have positive sign. On the other side, it would have negative sign. That's why if I call it plus, it has to be minus. Is this clear? Can you see the cursor? If this is plus, this has to be minus. On one side of that angular node, this plane, which is xy plane, on the one side of the xy plane, the wave function has to be plus. On the other side, it has to be minus. Please tell me whether you're following.
Yes, sir.
I can hear only one girl.
Yes,
What about
sir.
others?
Yes,
Yeah.
sir.
So this is plus, this is minus. But again, I know that radially, if I go outward at a distance 6 a0, it will become 0. So I'll have node. So then this, if this is plus, then after this node, in the direction it will become minus. On the other side, if this is minus, it will become plus. This is exactly what you see in your surface of constant probability plot. Okay, I can put it using a dot, and this is 3D x square minus y square.
Sir,
Yes, tell me.
so what is the difference between nodal surface and nodal plane? Are they similar?
See, nodal plane means it is plane is just a surface when it should be. See, nodal plane means just like a you put a plane like this. So it is
Like here the angular node is a plane, nodal
yeah.
plane.
In some cases, yeah, angular node is in this case it is a nodal plane. In this case, angular node is a plane here, xy plane. In this case. And the radial node is actually a surface, because you are going radially, you know, like a sphere going radially. Any direction you go radially, once we reach r equal to 6 a0, your function vanishes. So because of that, it has to be a surface. But in the case of angle, it is the plane, xy plane. That's why it's a plane. But in case of radial node, it is a surface. Okay, this is a surface. Because if you see 3D, so you understand now what I'm saying. In 3 dimension, you go from the center. Your I think this is not a good idea. I just go back to the previous slide. Something simpler. I had it, yeah, like here. Yeah. So sorry for the sound. Yeah, like this. So this is plus. Suddenly at r equal to 2 a0, it becomes 0. So I can go radially, and then I can go in any direction. It becomes 0. But for angular node, it is the same. I don't think in terms of r. I think in terms of theta or phi, isn't it? Theta or phi. It is a value of theta and phi. Okay, that gives you the angular node. Whenever for some value of theta or phi your wave function vanishes, then I call it angular node. You see in case the one I showed you, in this case it is a surface. It is a plane shown here. For example, even if I take this guy, which is your what is called like 2pz. What is this node? This is angular node. Okay. because when theta becomes 90 degree, then only you are basically, you remember the theta is this angle. Whenever you touch x-axis, it is along x-axis, it is 0. But it is not only along x-axis it is 0. It is if you go along any in the xy plane, if you go in any direction on the xy plane, okay. When z equal to 0 and xy plane means what? X and y has some value and z is 0. That you understand? How do you have defined plane?
Yes.
If I say xy plane, then x and y, they have some value, some finite value, and z is 0. So for when you fix z equal to 0, and then for any xy value, the wave function is 0. So that's why it's a plane. But radially means r. R has x, y, z all sitting there. If I go radially from the center, at what point the wave function hits 0? And then it's changing sign. That is your radial node. Since I'm going radially, going in different direction means what? I'm changing theta and phi, isn't it? If I go
Yes.
radially, I'm changing theta and phi. So that's why it's a surface. That's why it's not a plane. For example, the 3D z square, I told you, no, there's a two nodal, like you can say this is a plane. Actually, I should not say plane. These are like cones. There are two cones, and they are actually your nodal angular nodes. We have done it. So that you go and I think you do a little bit of practice. That is important. Once you do go through all this, I think you will. And this is for 3D x square minus y square, and you can do it yourself. This is a functional form, sin square theta cos 2 phi. You can do it yourself and see where do you find. Of course, again it is 3D x square minus y square. How many radial nodes are there? It is n minus l minus 1. 3 minus 2 minus 1. What is the value? 0. How many radial nodes?
0.
0. How many angular nodes? What is the value of L? 2.
2.
Yeah, that's right. The angular nodes are like x equal to plus minus y. Okay. And this is again the surface of constant probability of 3D z square. If I show you, I think with that, I think I'll just wrap up because we have so many things. But what I'm going to do, I'm going to send you this slide as well. Okay. I think it's enough for today. We're kind of done with hydrogen atom, but next Wednesday we'll do angular momentum. It's very important that you do angular momentum. And you will see that your total angular momentum operator will commute with the Hamiltonian of hydrogen atom. I hope you know. Some of you know, isn't it? L square commutes with H. Arko Prabhu, you know.
Yes, sir.
Yes, for hydrogen
Yes,
atom.
sir.
That we'll try to do. Okay. So tomorrow is the quiz, and I have sent you the instruction. I'll send you again. Hopefully, it will be in the assignment form, and we'll invigilate it online. So we'll send you Google Meet link. We'll divide you into small groups, 4 or 5 groups, and each of the group will get a link. I'll send an email saying that okay, this link is for this roll number to this roll number, like this. And for 812, there'll be a separate link. So you can just join using that link. Please switch on keep your video on, and please ensure that you have very stable internet tomorrow. So by 10:05, you should try to come online. Okay, it's 10:15 it starts. Not 10:15, 11:15 starts. So by 11:05, you should try to come online. And by 12:30, you have to scan it, make it a PDF, and upload it. Okay. So please don't delay, because I think for this 10 months quiz, 1 hour is enough. I've given you 1 hour 15 minutes. Okay. So with that, I think I'll wrap up today, and thank you very much for your attention. and I'm going to stop presenting, and I'm going to stop recording.